igneous rocks are endogenic. Sedimentary rocks are exogenic. So remember, endogenic is internally generated, means that the rock's heat source and energy source that created it came from the center of the earth. Those rocks were generated from an internal process. Sedimentary rocks are exogenic, externally generated. So what's happening to create a sedimentary rock is that it is the byproduct of other rocks. Those other rocks, over time, weather and erode, and then the sediment particles from those rocks are moved by wind or water and deposited into a low environment. So in this image, the artist is intending to show you that the sediment is coming from these environments. So we've got a great big U-shaped valley here. So over time, in this case, because it's U-shaped, a glacier came through, eroded all this stuff, and all its sediments came down the valley, found its way into the river, and then the river slowly deposits this material into the lake. And over generations, we've got lots and lots of different layers get deposited one season at a time, one flood event at a time. Every day, a little bit of something gets deposited in this low-lying area. So it could be the mouth of a river, a delta at the mouth of Hudson's Bay, or the Gulf of Mexico, or the Atlantic or the Pacific Ocean, anywhere where a river is emptying out into, or any low environment that wind is able to deposit particles into. What then happens is, over time, the weight of all of this material above starts to apply pressure and solidifies the lower layer. So the more stuff you have on top, the more compression of matter that you're going to have below. This process is called lithification right here. All right, and what we've got is a whole bunch of layers, which is that word stratigraphy again. So we've got stratigraphic layers of material which is deposited over time from these rocks up here. Now, sedimentary rock can be created from any other previous rock type. So the former rock structure could be other sedimentary rock, which could be mudstone, siltstone, sandstone. It could be it could be igneous rock. So it could be volcanic in nature, or it could be a pluton. It could be granitic. Or it could be igneous rocks, which we haven't discussed yet. All right, so these rocks, for the most part, have what are called clasts. Every little particle that was eroded and moved by some force, water, ice, wind, to another location, that particle is a clast. So a small clast will take a very little force and energy to move it. The larger the piece, the more force it took to move it. So those clasts, which make up sedimentary rock, tell a story of how much energy it took to move that rock and make this new sedimentary rock out of it based on the clast size. So with the structure of these layers, I've got lots and lots of stratigraphic conditions right here. And as I said, every layer will tell a story. It's sort of like a chapter in a book, so you can read a lot of information into it. And sedimentary rocks can also be made of organic material. So it's not just other rocks, that igneous, sedimentary, and metamorphic rocks, but it could also be the deposition of organic layers, like at the bottom of a marsh, for instance. And those organic layers become important fuel sources. Those are our petrochemicals often, and our coals. The darker the layer, usually but not always, is often very indicative of organic volumes. So in this picture here, what I really wanted to show you is how big clast sizes can get. So In this image right here, you can see that this little layer is pretty fine, and the class size, the particle size, is really small. And that means the river or the wind that was flowing through here was pretty gentle. It couldn't pick up bigger stuff. And it may have taken hundreds and hundreds of years to just lay down this little layer here, thousands of years, in fact. We get a little bit larger sizes of material through here, and those sizes tell me that the river became a little bit larger. It had more capacity and capability to move more stuff and bigger stuff. And consequently, when you get then really big stuff, and in this case, all the big stuff looks the same. It's the same color to me. It's almost like similar shapes. This tells me this all came down in one big flood event. So where I've got a layer here, which may have been laid down over hundreds and hundreds of years, this event was laid down probably in one big flood event. It may have the flood event may have taken quite a long time. Could have been flooding for a year or more. But this is what we've got. Between 3 and 1 here, I've got 3 flood events. A super large flood event. I've got lots of clasts and lots of big cobbles. I've got medium-sized cobbles in this flood event right here. And then I've got smaller cobbles and smaller clasts in this flood event here. So I can tell that there were at least 3 flood events in this situation. And I've got a whole bunch of finer grain material between all of these 3 big events that had taken place. So we've got 2 ways that these rocks can be made into sedimentary rock, and that's fluvial and aeolian. And we'll talk about fluvial and aeolian a little bit later, but I wanted to make sure that you guys had it. So fluvial is material that has been carried and possibly eroded by water action. So the class size here can vary a great deal, from microscopic to many miles across. And that sounds crazy, but fluvial can also include glacial, and glaciers can move big structures called megablocks. So the larger the rock size, the larger the class, the bigger the event that can take place. Aeolian is the movement of material through wind erosion, and wind has less mass than water, and therefore intrinsically can't carry the same size material. It's going to carry much smaller particles. However, certainly the faster the wind is, the higher the velocity of the wind is, the bigger the particle it can carry. So there's still that same principle there. It will never ever carry any significantly large characteristic structures. So some of these rock structures that you can see here are found in Arches National Monument here on the right. And Arches is a really neat place in Utah. These holes and these features in between and here in Monument Valley, these were carved out because a lot of the stuff that was in between here was actually salt, and the salt eroded out as a layer first and then left behind these fantastic features. So this is an aeolian deposited environment for the most part, with the exception of the salt layer. Most of this is fluvial in deposition, and lots of dark banding in here indicates that it is coal. And I happen to know that, because I know this location, that there is lots of coal here. Many events of deposition of organic material between dry periods that were produced in a shallow water body.